I have great pleasure in welcoming our third speaker, Jose Selvi, who's going to be talking about FIESTA, a HTTPS side channel party. Jose.
Thank you. Okay, can you hear me? Yes. Well, I was actually, a few weeks ago, I was preparing my slides, you know, and I was preparing my bio. And that moment, a friend sent me probably, which is the coolest bio ever. I don't know if you have seen that. Which, well, it's not anything that I could say about myself that is close in any way to this. So, well, my wife sometimes says that I'm a barbarian, but I'm not sure if it's something good or not. But, well, it's just me. I have been working in the security industry for some years, mainly as a penetration tester. I have worked in security consultancies in Spain. I used to work for another one here in the UK and in another company in the United States. At this moment, I work with Prosegur, which is a physical security company that started a cybersecurity branch recently, maybe 4 years or 3 years, which is recently. And I'm going to talk, well, I'm going to tell you a story that happens while I was doing an assessment in a client. And well, I'm going to talk the story, and at the end, I'm going to talk about what happened when I send all this to the vendors and you know what answers I got and everything, because I think it's interesting. The story begins in 2015, at the beginning, January, February. I was in a place somewhere in the world where everybody drives faster than me. And I was with a workmate, and we were doing an assessment, and we had like a system with different pieces, and we have devices and some websites. And in one of the websites, we had something like an administration application that was something, we could say, something similar to this. It had like a user database, probably synchronized with Active Directory or I don't know. And it kept my attention that it had a really powerful search engine. You were able to search almost everything. Tell me phone numbers starting by 1, by 2, by name containing ABC, whatever, ending with this string. It was really, really powerful. And I was thinking about this for a while, and other attacks that I have tested, that I learned in other conferences, such as crime and breach, came to my mind. And I started thinking about this kind of attacks. We'll see why. So I don't know if you know how side channel works, but there is a well-known example about the Pentagon and the pizza deliveries that I don't know if you have heard before. But I'm Spanish, and you know that we have a big problem with politicians and corruption. So this is like an example that it's easy to understand for me. Try to imagine that we have a politician, and we have, in one day, this guy has a car and a flat. And the following day, he has the same car and the same flat. And the following day, he has the flat, the car, a sports car, a house in the beach, a castle in Scotland, and a private jet. We haven't seen the suitcase full of money, but we are sure that something happened. Something happened here. Side channels is just like that. We haven't seen the action, but we see the environment, and we can see in the environment something that changed that can give us information about what happened. This is basically what a side channel is. In HTTP traffic, we all know that it starts with a DNS request, then the browser gets a first connection, or a first HTML code, and then it initiates more connections to get the resources that the browser needs to render the page. So this is basically how it works. When we talk about the TLS or HTTPS, what we see in the network is something like this. And what people usually think is that we can get information because it's encrypted. Yeah, well, it's not completely true. We can get some information. For example, we can see the DNS request, so we know where the user is connecting to. We can see the IP source and destination, so we can identify flows going to the server and back. We can see the certificate, and we can see the size of the information that is flowing from the server to the client and from the client to the server, which gives us some information. This has been used, the size of the response and the size of the request has been used as a side channel previously with the crime attack, with the breach attack. The difference is that the crime and breach use a specific property in compression that I don't know if you have ever used, have you ever played doing something like this? You can see the pointer. Well, it doesn't matter. If you try something like in the examples that I have written, you will see how actually this property in compression works. And the point is that if you put together a secret with a piece of information that an attacker can control, then you can leak information about that secret. Because if you try to guess one character, another, and your guess is matching another string which is compressed together, the size is not going to increase. And if you fail, the size is going to increase, right? This is how crime and breach works. Crime was doing this with TLS compression, flowing from the client to the server, and breach was doing the same in the opposite direction, right? But in this server that I was testing, there was some compression because people usually disable compression to protect their websites against this kind of attacks. But do you remember that we had a search engine with a really powerful search language? So try to think, if I send a search and I get no results, that the amount of information that the browser is receiving is just the HTML code and this kind of stuff. If I send a request that gets many results, I will get a response which is much bigger because it's the same than before, but with responses, for example. So it's a similar scenario that we have with crime and breach. If I can force the victim's browser to start connections and to make the request that I want, and I'm able to monitor from the network what's happening, how many bytes are transferred from the client to the server, or to the server, from the server to the client, I should be able to know if the request that I have tested was right or not. Are we agree with that? Who is agree with that? Okay. So knowing that, we have an oracle, and now we can play I think it's the who am I game, so we can ask questions. Try to imagine that we can do like a search that we know that is going to be wrong, a wrong guess, and we will get an amount of bytes that are transferred. So we can try to guess character by character, and then if we receive around the same amount of bytes that we receive with the wrong request, we know that it was wrong. And if we test with, we guess, and we receive more than that, it's because we are receiving results. So from the network, we know that we were succeed with the H in this case. So we can try with the following letter, with the following character, right? I told you that I was doing an assessment, and I don't know, well, I think you said most of you are developers, right? But there are some pen testers as well. Usually when we have assessments, we have like a very limited time to do. So we do really dirty stuff. We code something that we should be ashamed to share. But this is, I should be ashamed to share this. But this is the exploit that I use just to test that that was working and show it to the client. And basically, I prepare an HTML that was loading a PHP that was waiting for an amount of seconds and then redirecting to do the request that I want. So what I had was an HTML that was doing a try, waiting a second, doing another try, waiting a second, doing another try. And I used TCP down Wireshark to capture the traffic. And then I could show in the report that, well, this is the exploit. This is what I have captured. You can see that the guess with the third guess was right, and the third guess has a bigger size, right? So it was the way to prove that it was working at that moment. And at that moment, what I usually do when I find something that is special, I put it on the fridge for a while, I mean, some months, because it would be unfair if a client is paying for you to get vulnerabilities, and you find something weird or special, and in 2 days you are publishing it, because maybe they have this same issue in other places. So I put it on the fridge for, I think it was around a year, and in that year, somebody else published it, almost the same technique. I don't know exactly who, well, because they have presented this technique, and they were like 2 or 3 people, and sometimes has presented one, sometimes has presented the other. So I'm not sure. And the first conference that I have seen, it was in AppSec Israel, and it wasn't in English. So I couldn't understand the explanation of the guy that was presenting about the story of how they discovered the vulnerability. The only difference was what they were measuring the amount of time, which is similar to the size. More size, it takes more time to load an image, a resource, or whatever. But it was pretty much the same technique. But I still, I tried to search for the tool that they use for the demo, but I didn't find it. So I decided, okay, I still want to code something better than the dirty POC that I did. So I created a tool and I named it FIESTA. That, I named it FIESTA because I wanted to name it FIESTA. And then I tried to find something that could make sense to name it FIESTA. This tool is written in Python. It's available on my GitHub. And now we could say that this is the version 1, and I'm preparing the version 2, because when you start programming something, and then you program and you find problems and do a fix, and find another problem and do a fix, at the end you have something that maybe sometimes you think, okay, I should start from the scratch because I had too many fixes. And I want to prepare a version 2. I want to try to do it in Go, because I recently became a gopher. And yeah, because I like it. So how it works? It's very similar to how crime and breach works. The browser connects to a place where there is a web page loading a JavaScript, or the JavaScript is injected in a page that the browser is visiting using HTTP. And I can intercept and I can modify the content. And the server is sending the searches, is doing the requests that I want, and those requests are being relayed through a proxy, a TCP proxy. I mean, and sometimes I have discussions about this because people say, no, you can't intercept TLS. No, you can intercept TLS if you do it not in the application level. What you can do is to modify the application level, but you can relay a TLS connection if you want. If you don't touch the TLS, the application level, you can do it. So that's what I'm doing. And with this proxy, I'm counting the bytes, going back and forth. This is how the configuration file looks like. The point with this tool is that I wanted to code something that I don't need to recode each time that I find a new vulnerability similar to this. So I try that what you have to do is a configuration file per each vulnerable site. So I'm going to show you with a fake web, which is very similar to the original web where everything began, and is this. You will see that, let's see. Okay, this is my browser, and the terminal is in a Linux box, which is in the middle. I have been in the middle somewhere, doing a technique of man in the middle in the network, whatever, or he's connecting to my hotspot or whatever. What you see here are the images, because this use a very simple approach, which is that I'm doing the requests, like creating images that do those requests. So you can see there that I'm testing all the numbers and then the following number, and you could see that I started with a word because I wanted the phone number from a specific person, and Fiesta is guessing the phone number by number. Because I told in the configuration file, I had a car set that was from 0 to 9. So it's just doing that. And at the end, I think I can speed this up. At the end, yeah. At the end, I don't know if you can see the number or it's too small. You can see the number? Can you verify that this is the same that Johansson? And this is from the network. This is from the network. And I did another, well, it has another feature, this tool, that I could use because I said, okay, look for a number which is together with this name. So I'm getting that phone number. But you can just say, okay, search everything which is next to an @ and I'm grabbing emails, one, the other. I mean, it's not just a tool that you can use to extract one data. You can extract everything with some minutes. If you are in the middle, if somebody connects to a Wi-Fi that you can control, you can use this. and you can get information, I mean, everything. If you have more time, more information. Okay, when I was trying to use this tool, I found several problems. So we are going to talk about them. One of them was that most of the time, the information that is shown from the request is not in that HTML response. So we can't just load the request as an image, because what the application does is to render the HTML and then using JavaScript or whatever, connecting to an API and getting the data. So I implemented to use different techniques. You can say, OK, I want to load in an iframe. So this is going to be rendered, or in a separate window. And you are able to say that you don't want the first connection, that you want the second, the third, the fourth, or the first, which request was bigger than this amount of bytes, which is really useful, because usually this kind of calls to API has a token to protect from other people to connecting to that API. So are usually bigger than that. What about HTTP2? Well, HTTP2 has a property. Well, we had a really good talk yesterday about this. I don't know if you were attending to it, but I was. And one of the properties on HTTP2 is that the browser sends all the requests and is receiving their responses in a random order. I mean, I don't know if I want to get the amount of bytes that were transmitted in the third response. I have no way to know which one was the third response. So what can we do this? Well, as the song, despacito, step to step. So I did something, I developed something in the tool that you have to activate that flag in the configuration file, because if not, the performance, it impacts the performance. But what I do is, OK, when the request, I have three requests. So what I do is, OK, I hold on the second and the third, and I let the first one to go forward. Then I wait to get that request. And then I let the second one to move forward. And then I do the same with the third. So somehow I'm demultiplexing the HTTP2 connection. So now I can see the response that I want, and I can measure the amount of bytes. Okay? And you have, this is just an example that I borrow from Akamai that has this side where you can see the differences. So you have on the left how it works, how HTTP 1.1 works. On the right, how HTTP 2 works, loading like randomly. And in the middle, you have how HTTP 2, I mean, this exactly this, how it works when it's going through FIESTA. And you can see that it's one by one. I'm forcing it to go one by one, despacito, step to step. OK? But when I try to use this tool with the most well-known internet firms, I was really excited because I thought, OK, in clients it has worked in the last few months. This is going to work with these companies, but it was really disappointing. It didn't work at all. It only worked in one place, and was HackerOne. Because HackerOne, when you has a search box, and when you search there, it has an API call, and that API is not protected with that token that we call that people usually use. So you can use the technique that we see in the first demo with the images. You can use it with HackerOne. The only point is that you can search character by character. You have to search word by word, but the tool supports word list. So you can somehow search a company, names of vulnerabilities, and you can get some information. Not all of them, but some information. But I was something that is, it's difficult for me to give up. So what I was thinking and thinking more, and at some point I realized about something that happens when you search in your contacts, for example, in Google. How many images are loading? Well, it seems that you get the page is loading an image per each result plus one, which is your image here. And those are images, are not icon, well, are images. It doesn't matter if the contact has an image or it has the default image. It is an image. So I did a quick test. OK, so if I do a search and I don't have results, I have one image loaded. And if I have one result, I have two images loaded. And actually, Google is loading the images from a CDN specific for static content, so it's really easy to identify in the network how many connections the page did to that site. So seems to be a possible oracle. I had a problem testing this that images are cached. So if I do a search and I get 10 results, those 10 images are cached. So if I try the next one, even if it's a right guess, there aren't connections because they are cached. But we are in the middle, and the connections are going through my TCP proxy. What happens if I close the connection before the browser gets the response? I see the connection, I count how many connections, but it's not cached because the browser didn't receive the response. And even if the browser retries 2, 3, 5 times, it doesn't matter as long as it's a static number of times, because what I need is to see a difference between a right guess and a wrong guess, and we can do it in this way. And what happens with the first? With the first connection, it could happen that you have all the images cached. But I found a trick, which is that when you connect, for example, to a website that is this kind of companies, you connect, for example, if I'm from Spain, if I connect from Spain and connecting to a server, and the server is in Madrid, and the content, the static content that the server is linking is based in a CDN in Madrid. So if we are in London and you have cached, your browser has cached the content of images that were hosted in a server in the UK, for example. What happens if I redirect your traffic to Brazil? This server in Brazil will, you are coming from a Brazilian IP because I'm routing your communications, will get, it will give you images that are hosted in Brazil. And those images are not cached in your browser. So the party starts with that. We can start doing this technique. Yeah. This is an example of the configuration file. I'm moving fast because we only have a few minutes. More examples in the real world. Google Inbox, which give access to your emails if you are a Gmail user. It has the same. It loads an avatar, so the same technique you can use, the same technique. Google Drive, same with the preview. You search, you have the files, and it loads a preview on each file. So you have the same Oracle here. And even you can search strings that are in the content of the files, not just the name. Dropbox. This is interesting because Dropbox doesn't load a preview, but it loads an image when nothing was found. So we have the same Oracle, because if it loads one image, it was a wrong guess. And if it loads no images, it was a right guess. Facebook Messenger, same. You search in your conversations, and if it has two matches, it loads two avatars. And you can see those avatars loaded from the network. And I have a demo. This demo with Google Contacts. You can see the phone number, so you can see that it matches. And we have Wolverine's phone number, which is something that I always wanted to have. What I have learned from bug bounties, I set this to all these places that you have seen, and I received very different answers. One thing that I realized is that probably people managing bug bounties are handling a lot of crap. And what happens is that if you have a well-known name in the security industry, they pay more attention than if you are one guy that is sending something. What happened? Well, I sent this. HackerOne said that that was a duplicate from 2 years ago. Somebody else did said them that, and they won't fix. It was a won't fix, so it should be still there. Same with Google. So everything that you have seen this week was working at least, and they said they are not going to fix it. They said something about a browser problem. Maybe this is a browser problem, but I didn't understand why it's a browser problem really. So Facebook and Dropbox fixed it. So this doesn't work now in Facebook and Dropbox. And yeah, I had to push with Facebook because the first answer was one fix, and I pushed them I pushed to all of them. But at the end, Facebook fixed it. And they did an interesting fix because I was thinking about adding an anti-cross-site request forgery token as a fix for this. But they do something that was, in my opinion, smart, probably because adding that token impacts on performance or something. But what they did was to add a box that when the search, the origin of the search was not the Facebook page, it shows this box, and you have to accept, well, sorry, it's in Spanish, accept in order to make the search. So if you are with a JavaScript running these connections, the images are not loaded at all. One concern that they had, well, they had two concerns with this vulnerability. One was that man in the middle is required. And in bug bounties, or in general, many people think that, well, you need man in the middle, so it's not that critical. But, well, I disagree, but it's a personal opinion. But the other one was, okay, but in your technique, you see you see that window, and users are going to realize that something is happening. Well, I am showing that window intentionally, on purpose. Why? First, because in Spain we have some kind of anti-hacking law. So if you code a tool, it has to be a tool for testing, not a tool for attacking. And I can be in trouble if, well, probably I could have done more to hide the window without having legal problems, but I will try to keep safe. And the second one was because I thought that wasn't, hiding a window, this is a different problem that I think has nothing to do with the technique that I'm presenting. So, but as several people told me about that, I have had a couple of examples about how we could hide this window. The first one is, I don't know if you know, do you know this YouTube channel? It's really cool. This guy is talking about very interesting stuff, and he has some videos where he's getting a pop-under technique, well, several pop-under techniques, and he's doing reverse engineering, and then he's getting the trick. So these are techniques where they are using a trick, and the pop-up is not a pop-up, it's a pop-under. It's opening just behind the browser, so it's hidden. Or you can hide the tab. For example, this is an example that I did with this newspaper. I don't know if you see that something is happening in this tab. You can see that? We are going, but nothing is happening now. Well, we can see that moving the tab, that is easy to see, what was happening. So we have the JavaScript running here, and this is like the window that is behind is like the small window that I was using before. And I have a JavaScript running here that is loading in the hidden tab all the requests that I want. And when I see that the pointer is out of my page, I change it to the old one. So for the user, especially if it has, how many of you used to have more than 10 tabs in the browser? It's difficult to see that a page, a tab is, doing this. So this technique, I think I can implement this in the new version of the tool without being in jail, I think. So I will add it. Not the other one because it's a specific, we could say vulnerability in the browser, and they are always fixing it, and then another technique, and then fixing it again, and I don't have enough time to go to that speed. And that's all. Thank you very much for your attention, and if you have questions.
Any questions for Jose?
Thanks for the talk. First off, I thought it was very interesting.
Thank you.
So obviously the key thing is that it's a differentiation of the content size that you get back. When you filled out the bug bounties, what remediation action did you provide? Did you think the Facebook remediation was enough to resolve this, or have you got any other opinions for remediation?
Yeah, well, at the end, you can do different stuff, but I think blocking the possibility of doing many requests from the JavaScript kills the technique because, well, yeah, kills the technique, basically. You can do other stuff. You can block if you have many requests, but the attacker could ask specific 3 questions still, and controlling that you are loading always the same amount of images, I think it's really complicated.
So I also noticed, so a lot of the sites that you tested on never had adverts. Sites that would have adverts, would that change the content size per request because it'd load different adverts, I'd assume?
The content size, well, there are some pages that are changing the content size to avoid these kind of techniques, but they are doing it with the HTML or content, but not the images.
Okay.
Thank you.
Any more time for a couple of quick before we rush the food? Okay, if there's no more questions, can I ask you to use the voting slips at the back, red or green for really good, red for bad, and put them in the appropriate bowl. Or if you can make comments on the shared site, you can leave free text comments. Please do so. It should be open for another 5 or 6 days. I'd like to thank Jose again. Thank you very much.
Thank you very much.